Hello, Integrated Math 1. Welcome to lesson 2.3.5. We're going to keep playing with systems of linear inequalities. But before we do, I would like you to do a quick warm-up over on page M2-217. We're just going to do number one. I know there's others, but we're just going to do number one. I would like you to determine whether the point 1, 7 is a solution to the system. So plug in for X, plug in for Y, see if it's true. And remember, in order to be a solution, it has to be true for both equations, not just one of them. So you do have to check both. So go ahead, hit pause, plug in and see if it's a solution, and then hit play when you're ready to check your work. So as I said, first of all, we're going to plug in, right? So everywhere I see an X, I'm going to plug in a 1. Everywhere I see a Y, I'm going to plug in 7. So I'll start off just by doing 4 times 1 minus 7. 4 times 1 is, of course, 4. 4 minus 7 is negative 3. Awesome. It works. It's true. Let's plug it into the other equation. So negative 2 times 1 plus 7. Well, negative 2 times 1 is negative 2. Negative 2 plus 7 is 5. Oh, which does equal 5. So, yay, 1, 7 is a solution to this system. So remember, the deal is that in order to be a solution, it has to be true for both statements, not just one. It has to be true for all of the statements in the system. So we've already been solving systems of equations. We did that in the previous time. And more recently, we've been solving systems of inequalities where we graph them, we see where they overlap. Now, we've been used to just having 2 equations or 2 inequalities, but you can have more than 2. And remember how we call them constraints? The idea is that these inequalities are kind of hemming in a chunk of our graph with our solutions. So we're going to be exploring that just a little bit more today. And so along those lines, our goals, we're going to use various methods of solving systems of equations to determine the better buy, better job offer, solve systems of linear inequalities. This is what we're really going to focus on. We're going to solve systems of linear inequalities with more than 2 inequalities and see what happens when we put these on a graph. We're going to graph the solution to a system of linear inequalities in 2 variables as the intersection of the corresponding half plane. So remember, the idea is where they overlap, that's where the solutions are, right? That's the deal. So you solve systems of linear equations by graphing, by using substitution, by using linear combinations or elimination. We called it that as well. More recently, of course, we've also graphed systems of linear inequalities to determine possible solutions, right? We know it's a whole chunk of the graph, and anything within that chunk of the graph is a solution. So how can you use these various methods to reason about real-world problems? So let's step this up a little bit. We're on page 218, M2-218. Let's talk about systems as far as summer savings goes. So a neighborhood pool club offers 2 membership plans. Plan A includes a seasonal sign-up fee of $100 and charges $2 each time you use the pool. So you can sign up for $100 for their membership or whatever, and then pay $2 every time you go to the pool. Plan B has no sign-up fee, okay? So you don't have to pay for a membership, but charges $6 each time you use the pool. Now, Susan chooses plan A. She has a budget of $200 to spend on pool fees during the months of July and August. Now, Susan wants to be sure she uses the pool enough times so that the plan she chooses works out to be the better deal between the 2 plans, but she does not want to go over her budget. Fair enough. So this sounds like a complicated situation, that too. So what I'd like you to do, can we just start by using a system of linear equations, a system of linear inequalities, to make recommendations to Susan, to make a recommendation to Susan as to how often she should use the pool in July and August. So go ahead, hit pause, see if you can come up with some inequalities or equations to help her figure out how she knows she's getting the better deal. So go ahead, hit pause, see what you can do with this, hit play when you're ready to check your work. Now there's a lot happening here, right? There's a lot happening here. So I need some space. So Plan A had a sign-up fee of $100, charged $2 each time you use the pool. Plan B had no sign-up fee, but it's $6 each time you use the pool. She chose Plan A. She has a budget of $200, doesn't want to go over budget. Oh my gosh. Okay, Susan. Let's talk about linear equations for just a second, okay? So we know that it's a $100 sign-up fee plus $2 every time she uses the pool. So that's a $100 sign-up fee plus 2 times however many times she uses the pool, and that'll tell her the total amount. Or that's Plan A. Or if she went with Plan B, of course, if she went with Plan B, it would just be $6 times every time she uses the pool, and that would equal her total cost. So this is all fine and good for a system of linear equations. I'm going to erase this so that you can see the pretty version. There it is. It's there, pretty. And of course, we could totally solve this, right? We could solve this. These are both equal to y, so everywhere I see a y, I can replace it with 6x. So instead of y equals 2x plus 100, I can say that 6x equals 2x plus 100. I'm going to go ahead and subtract 2x from both sides. 6x minus 2x is, of course, 4x, and that now equals 100. If we divide by 4, I believe that gives us 25. So I'll plug this in, and I don't care which equation you plug it into. I'm going to plug it in the second one because why not? So instead of 6 times x, we'll do 6 times 25, which is 150. So here's the deal. The two plans will cost the same if she uses the pool 25 times. If she uses the pool 25 times, it's going to cost her $150. Whether she picks Plan A or Plan B, if she uses the pool 25 times, it's going to cost her $150. So this means, and sorry, I'm in the way. This means that Susan will need to use the pool more than 25 times to get the better deal between the plans. Because she picked Plan A, she's going to want to use the pool more than 25 times in order to get her money's worth out of it. So let's see how that translates into some linear inequalities, right? So let's talk about systems of linear inequalities. And we'll say, because she's going to use it in July and August, so I'm just going to say that A is the number of times she uses the pool in July, B is the number of times she uses the pool in August. Hooray. And we're saying that together, she needs to use the pool more than 25 times, okay? So I know that A, oh dear, I'm hitting buttons. I know that A plus B has to be greater than or equal. Actually, I didn't want equal to. I wanted to be greater than because we just want to get the better deal. Goodbye. Ha. So I want number of times in July and August to be more than 25 times so that she feels like she's getting a better idea. Now, here's the thing. She also doesn't want to go over her $200 budget, right? That was the deal. She needs to stay under that budget. So real quick, I'm going to do some work here. That whole 2x plus 100 is going to max out at $200, right? We don't want to go over that $200. So I'm just going to do some quick work here. I've got 2x equals 100. If we divide by 2, that means x equals 50. Okay. So if she goes to the pool more than 50 times, she's going to go over budget. So I'm also going to say, so yes, A plus B should be more than 25. She needs to go more than 25 times. But A plus B also has to be less than or equal to 50. Because if she goes more than 50 times, she's going to go over her budget of $200. Yeah, hang on. I'm going to erase all this stuff. I'm going to clean that up. Oh, and we'll show the typed bit. So any combination of trips to the pool in July and August should add to more than 25 and no more than 50 in order to A, get the best deal. More than 25 gets her the best deal. And under 50, which helps her stay under her budget. So this is a funny little situation where we actually use a system of linear equations to help us create our system of inequalities. We're skipping a good bit here. That's okay. We're just going to go straight for the inequalities since that's what we're worried about. So let's go over to page M2-221. Now, we've still just had 2 inequalities in our equations, but we said that you could have more than that, right? We can have more constraints on our system. That's okay. So I have a situation here, Miguel. So Miguel's eye doctor informed him that he needs glasses. Now, luckily, the local vision store is having a sale on all eyeglass frames. And the advertisement in the window is as shown. You can see your lovely little ad here. Save 60% to 75% on all frames, regularly priced at $120 to $360. Ding. Now, previously you solved a system containing 2 linear inequalities. However, a system can consist of more than 2 linear inequalities. So what I would like you to do, we're gonna work our way into this. I would like you to use the advertisement to write 2 inequalities, we'll just start with 2, that represent the regular price of eyeglass frames. And let R represent the regular price of the frames, okay? Don't overthink it, just hit pause, write down 2 inequalities that represent the regular price of the frames using R for that variable. Go ahead, hit pause, write it down, hit play to keep going. So the ad says that the regular price is between $120 and $360. So I know my regular priced frames are going to be greater than or equal to $120. And they're also going to be less than or equal to $360, right? Because that's the max on our deal there. Oh, look, we just wrote 2 inequalities. Yay. All right. But there's more to this ad. So we use the regularly priced deal to figure out, okay, that's what it's going to cost, but what the regular price is. We wrote 2 inequalities. But now I'd like you to use the same advertisement to write 2 inequalities that represent the reduced price of the eyeglass frames. Let S, and we'll use S, we'll call it the sale price. Instead of reduced price, can we call it the sale price? And we'll let S represent the sale price of the frames. So we know we're saving 60 to 75% on our frames. Go ahead, hit pause, give it some thought and hit pause, see what you can write out, what you can come up with, and then hit play when you're ready to check your work. There is a hint off to the side on the screen there. Hit pause, then hit play when you're ready to keep going. So this says something interesting over here. When an item is 20% off the regular price, you can think of that item costing 80% of the regular price. So I'm going to rewrite these a little bit. If I'm saving 60%, that means I would actually be paying 40%, right? All percents are out of 100. If I'm saving 75%, that means I'm actually paying 25%. Ooh. So let's write an inequality for each one of these. So my sale price is between 40% and 25%. Actually, I guess it's backwards, right? 25% and 40% because we start with the least. So I would say I don't want to do a percent. Percents I write as decimals, so 0.25. So I would do 0.25 times the regular price, right? And my sale price is between that and what's the other one then? 0.4. I guess I could put 0.40R, but I'm not. I'm just going to put 0.4R. So that means S is greater than or equal to this one and less than or equal to that one. It's between 25 and 40% is what it's going to cost me. Oh, I should put the word and in here. Oh, look, we have another inequality. This isn't very pretty. Let me erase these and put the typed one up. Put the typed one up. It's all pretty. Ooh, there it is. All typed and pretty. So yeah, my sale price is going to be, I'm going to pay between 25% of the regular price and 40% of the regular price. It's actually it's a really good sale. I wonder where this place is. Might need to figure that out. Just saying. All right, we now have 4 inequalities. Heather wrote the system of linear inequalities for the problem situation. Explain why it's incorrect. Can you hit pause, look at Heather's work, look at what we wrote earlier and look at Heather's work? And can you hit pause and write down what she did wrong and then hit play to keep the discussion going, please? So the first ones were fine, right? The regular price is between $120 and $360. That was fine. The sale price is the issue, right? She forgot. She gets 60% off. She doesn't pay 60%. So Heather correctly wrote the inequalities for the regular price, but she incorrectly wrote the inequalities for the percent off of the regular price. Her inequalities mistakenly indicate that the sale price of the glasses is only 25 and 40% off the regular price. So she made an easy mistake. She just got these numbers mixed up, and that's okay. That's an easy mistake to make and an easy one to fix. So let us use our system of inequalities. And I want you to graph all of them. Hit pause, work it out, hit play when you're ready to check your work. Pardon me. Sorry, you gotta listen to me take a drink of my drink. But hopefully you're back by now. So let's graph all of these. It looks like the regular price is my x-axis, the sale price is my y-axis. So let's see what we can do. R is greater than or equal to 120. Well, here is where R is 120. And if R is everything greater than that, that means R is everything to the right. So I'm just going to draw a line, a vertical line right through it. And then I'm going to use my highlighter, actually. I'm going to use a highlighter here. And we said that it's everything to the right. Woo, so everything over here. We also said that R is less than, let me bring my pen back here for a moment. We also said that R is less than or equal to 360. So here's 360, so put a dot here. If it's everything less than that, it's everything to the left, right? Left is less than. So we'll make a vertical line, and ooh, I need to color everything to the left. So let me grab a highlighter of a different color. And we color everything to the left. Whoa. Well, so far everything overlaps. So far it's everything in between these guys. Let's deal with the others, shall we? So I have S is greater than or equal to 0.25 R. If you want, you could think of it as a plus 0 on the end. So my y-intercept is 0. It says 0.25, but you could even think of it as 1/4 if you wanted to, right? It's a quarter. So up 1/4. However you want to do this, we're going to write our line right through it. It is a solid line because there's an equal sign there. And it says S is greater than that. So that means I'm going to grab another color, people. And I'm going to highlight, it says greater than that. So I want to highlight everything up above that. Whoa. That's a lot of highlighting. Well, so it looks like everything's overlapping up here, but wait, there's one more equation. S is less than or equal to 0.4 R. And again, you can think of it as a plus 0. So again, my y-intercept is 0. Huzzah, that's not going to change. My slope is 4/10. You could think of it as 4/10 or 2/5, however you want to think of it. So up and over puts us about here. It's about there. And we'll solid line, shoo, right through it. And I'm going to highlight one more time. I'm going to grab the orange highlighter. Maybe I'm going to grab the orange highlighter. Yes, I am. And it says S is less than or equal to that. So that means it needs to be everything under this line. So I'm going to color in all underneath this line. I'm coloring. All right. That is a lot of inequalities. That is a lot of highlighting. Can you clean this up a little bit? Can you just shade the portion of the graph that satisfies the system of linear inequalities? We had way too much shading there and it's messy, so you might want to erase a little bit. Can you shade just the region where they all overlap? And what shape does the solution resemble, actually, now we're thinking about it? Go ahead, hit pause, shade the section where everything overlaps, and hit play when you're ready to check your work. So I erased all my shading, and I realized it was between these guys and between these guys. Oh, so it has to be this little chunk in here. Ooh. And it kind of looks like a trapezoid. We'll play more with trapezoids and shapes and all that, more geometry type stuff on the coordinate plane in the next unit. But for now, yeah, I've got I got one set of parallel sides, right? Two sides that are parallel. That certainly makes that a trapezoid. Good job, us. So about how much would Michael expect to spend if he purchases eyeglasses that are regularly priced at $320? Use the graph and hit pause. Find 320 on the regular price, go up into your shaded region, and then check your y-axis for your sale price. How much should he be expecting to pay? Hit pause, see what you can do with this, hit play when you're ready to check your work. You ready? So I want my pen back. I want my red pen back. So $320, there it is. So if I go to $320 and I go into the shaded region, that's here, right? That's here. So if I come across, not perfect, but it looks like that's what, about $130? If I come across here, again, sorry, it's not perfect, about $80. So it looks like if Miguel purchases a set of eyeglasses that are regularly priced at $320, he should expect to pay between $80 and $130 for those glasses. Yeah. So it's regularly priced as $320, but if we use our little graph here, it looks like the sale price is going to be between $80 and $130. So that just kind of helps him budget, right? That just kind of helps him know what to expect. So Miguel is definitely going to purchase a pair of eyeglasses that are on sale, right? I mean, why wouldn't you at this point in time? What is the least amount of money Miguel can expect to spend? And what is the greatest amount of money he can expect to spend? Use our lovely graph. Go ahead, hit pause, see what you can do with this, and then hit play when you're ready to check your work. So if we're looking for the least amount he's going to spend on sale glasses, then we need to look at the lowest point in our shaded region, which appears to be right about there. And that's what? About $30. So it looks like the least amount of money he would expect to spend would be $30. And if we want to know the greatest amount, well, we need to look for the highest point in our shaded region, which of course is up here. And so if we come across, boom. So it looks like the greatest amount he can expect to spend is $140. So the least amount of money he can expect to spend is $30 if he purchases eyeglasses that are regularly priced at $120. And the greatest amount he can expect to spend is $140 if he buys eyeglasses that are regularly priced at $360. So somewhere a little more than 140. I think it's not quite the highest point, but you get the idea. So again, this just kind of helps him know what budget he's looking at when he goes in. It helps. Now, Miguel decides to buy a pair of eyeglasses that are regularly priced at $240. Can Miguel expect to save more or less than $140 off the purchase price of this pair of eyeglasses? And you're going to use the graph to determine an approximate answer. So go ahead, hit pause, use the graph to help you answer the question, hit play to check your work. You ready? So regularly priced is 240. So 240 regularly priced, and here it is in the shaded region between these guys, right? Somewhere in here. So if we kind of come across, it's more than 90. That's what that looks like what, $98, $95? I don't know, something like that. And of course, if we come across here, it looks like it's about $60. So according to the graph, it's not perfect. According to the graph, Miguel can expect to spend between $60 and $96 for eyeglasses that are regularly priced at $240. But the question says, is he going to save more or less than $140? Well, let's find the difference, right? If we find the difference of these guys, 240, I have a calculator here to help me out. 240 minus 60 means you'd be saving $180. 240 minus 96 means you'd be saving $144. Yeah, he's going to be saving somewhere between $144 and $180, and that's more than a savings of $140. So he is going to save more than $140 on his classes. Good job, Miguel. Last but not least, let's use algebra to determine the greatest amount of money Miguel can save by purchasing eyeglasses that are regularly priced at $240. Remember how this was kind of hard to estimate, where I was like, well, 95, 96, I don't know, something like that. Can you use our inequalities and use a little bit of algebra to try to figure that out? Go ahead, hit pause to work that out, and then hit play when you're ready to check your work. So what we're going to do is I'm going to substitute $240 for R. I'm going to substitute $240 for R and the greater discount of 75% and solve for S. So if I remember, we had S is greater than or equal to 0.25 R. So fine, I have a calculator, 0.25 times 240 is $60. Awesome. And that's the greatest amount of money he would save. So then if we did 240 minus 60, it looks like the least amount of money he can spend on that purchase is $60. So the greatest amount of money he would save is $180. Is your head spinning a little bit now? Maybe just a little. As always, I hope you at least found this a little helpful, a little useful. If you have questions or concerns, come talk to me. You know I'm around, and I'll see you guys later. Bye.